Uh, we'll wait for a few minutes and then we'll start the session. We'll wait for others to join in. Hello, am I audible? Hello, am I audible? Okay,
Yes, sir, audible.
okay. Uh, so I'll start the session now. I think I'm just muting you, Tarachand. Is that fine?
Yes, sir.
I'm not able to hear you.
Yes, sir,
The audio.
I'm already waiting for your.
Okay, I'll start the class now. Uh, I'll just start the class now. And if you guys have any questions, you can just type it out in the chat box. And I'll just mute.
Sir, one more thing, sir. One more thing, sir.
Yeah.
In my English subject, sir, when I'm trying to do the assignment, like assignment, it is too difficult to mark it down. Try to give me smallest class, so immediately, very not difficult to do the assignment.
Uh,
First,
uh, Bosu Babu.
yes,
Uh,
sir.
yeah, actually, I'm unable to hear you right now because there's a lot of interference. Can you type out in the chat box what you want to say?
Yes, sir. Yes, sir.
Okay. Okay, I'm going to start the session now, and whatever questions or doubts you have, you can ask me in the chat box. So, my name is Anurag Gupta. I'm a teaching assistant for this course. So the format of the live sessions are as follows. I'll be discussing certain MCQ based questions, which will cover certain concepts. I'll give you guys 30 seconds to respond. I will first display the question on the screen. Then I'll give you guys 30 seconds to respond, 30 to 40 seconds based on the type of question. And then I'll go in depth and discuss the question, the MCQ question in detail. So that is how we have conducted our previous two live sessions. And towards the end of the live session, if you guys have any general questions related to that week's content, I can take that. Uh, so, Bosu Babu, if you had any, you were saying something. You can just type that in the chat box because I was unable to hear you. There was a lot of interference in the sound. Uh, so for now, I'll just get started and then okay. Please give at least intermediate level. Okay. Uh, so the actually the assignments are not set by me, but I can convey this message to the other to the course instructor and the TA as well. So the other TA who set the assignment. So yeah, I can convey this message to them. Bosu. Okay. Okay, I'll get started with the session now. Okay. Okay, Bosu Babu, I'll convey your message to the course instructor as well regarding the assignment.
Thank you, sir.
Okay, so last week we had stopped at question 5. So we are still discussing the week two's content. which we were not able to finish last week. There are many more questions. So we'll get started with, we'll continue where we left off last week. So this is question 6. After release of neurotransmitters into the cleft, they are deactivated by A. Nicotinic cholinergic receptors, B. Choline acetyl transferase, C. Acetylcholine esterase, and D. Synaptotagmin. So I'll give you 30 minutes to answer this question, 30 seconds to answer this question, and then I'll discuss this question in detail. You can type your answer in the chat box. I'll just set a timer for 30 seconds. Your answer does not need to be right. You can also take a guess. Even if it is wrong, it does not matter. And then I can discuss the question in detail. Okay, let's see what are the answers. B. Okay, B, B, D. 3 people have told B and 1 person has said B. Okay. So we want to see what is deactivating. This is the crux of the question. What? How are they? How is the neurotransmitter deactivated? Uh, so the first option is uh, nicotinic cholinergic receptors. So this is wrong because the neurotransmitter acetylcholine attaches to nicotinic cholinergic receptors. It is not deactivated by nicotinic cholinergic receptors. So if you recall, once the acetylcholine is released into the synapse, it travels via diffusion to the postsynaptic membrane and attaches to nicotinic cholinergic receptors, and it works like a lock and key mechanism. So the as soon as acetylcholine attaches to nicotinic cholinergic receptors, uh, uh, these receptors open up and allow sodium to uh, uh, go into the postsynaptic membrane, postsynaptic cell, causing an end plate potential. So this is not the correct answer. Uh, the second option is choline acetyl transferase. This is not. This is also not the correct answer because uh, uh, the reason this is not the answer is because let us recall what choline acetyl transferase does. So this is the uh, presynaptic neuron, and we have action potential that comes in. So here, what choline acetyl transferase does is, it's for short, it is CHAT. What choline acetyl transferase does is it combines choline, which is in the presynaptic end bulb, with acetyl coenzyme A to make acetylcholine, and it packs this into vesicles. So we have ACH packed into vesicles. So this reaction is mediated by choline acetyl transferase. So you can just get a hint of what this is by this word transferase. This might make it easy for you to remember. So this is basically involved in the transfer of this ACH. So yeah, then the third option is acetylcholine esterase. This is the correct answer because you can see, you can also remember by the name erase, esterase or erase. You can just try to remember using this. What it does is, we have ACH here, and this is the pre synaptic neuron. This is the post synaptic neuron, and ACH is released here, and then we have acetylcholine esterase, which breaks this down into choline, and acetate. Okay, and the reason why this is done is this is to control the action of ACH. This is like a feedback mechanism. This is like a control mechanism. If there is, if ACH is uncontrolled in this region, what will happen is it will generate a lot of uh, action potentials, and this can lead to uh, this can lead to rigidity. Okay, in the muscles, because if there's a lot of action potentials that are generated continuously, then what will happen is the muscles will always be in a contracted state, and that will lead to rigidity of the muscles. So we need to control the action of acetylcholine. So some of it is broken down. Some of the acetylcholine that is released into the synapse is broken down into choline and acetate by this particular uh, chemical here, acetylcholine esterase. And synaptotagmin is not the correct answer, because if you recall, the vesicle which has acetylcholine has a calcium receptor on the vesicle has a calcium receptor called synaptotagmin. So this receptor basically uh, senses an increase in calcium concentration within this region, and once it senses this, it starts to move this vesicle towards the this membrane here. So that is the role of synaptotagmin. So the correct answer is acetylcholine esterase. So you can just remember this esterase as in erase. You can remember this particular word, and the basically the action of this is to erase acetylcholine, some of it, not all of course, some of it. So this is the explanation. Let's go on to the next question. Lambert-Eaton syndrome is associated with A. Inability to pack acetylcholine into vesicles. B. Blocking of nicotinic cholinergic receptors. C. Damage to voltage-gated calcium channels in the axon terminal. And D. Absence of inhibitory neurotransmitters like GABA in the synaptic cleft. So you can just write down your answer here. You can just, I'll give you 30 seconds, and then we'll discuss this particular question. Okay, let's see what the answers are. Okay, A and C. So two people have told A and C. Okay, A, C, D. Okay, let me just write down those options here. A, C, D. Okay, so let us go through this particular question, each option here one by one. Inability to pack acetylcholine into vesicles. Uh, so this is not. So first, let us recall what is this. Lambert-Eaton syndrome is a autoimmune disorder. Here, the immune system of the body wrongly perceives one of the wrongly attacks uh, an important part of the process of transmission of signals across the synapse. So we'll discuss what that is, what particular aspect it the immune system effects. So first is inability to pack acetylcholine into vesicles. So this is caused by something else, a neurotoxin called uh, vesamicol, right? So what vesamicol does is it prevents this chat choline acetyl transferase from packing the ACH that is created into vesicles. So if it is not packed into vesicles, it cannot be released into the synapse or the neuromuscular junction, and hence an end plate potential will not be generated in the postsynaptic terminal, postsynaptic membrane. So yeah, this is not the answer. Blocking of nicotinic cholinergic receptors. So blocking of nicotinic cholinergic receptors is caused by this neurotoxin called tuberculin. I don't know whether the spelling is correct. Uh, Let me just make this silent. Yeah, so it is caused by a chemical called tuberculin, which blocks the nicotinic cholinergic receptors. So this is again the wrong answer. Also, there's another autoimmune disorder called myasthenia. I think it's called myasthenia gravis, which uh, which attacks the nicotinic cholinergic receptors, again blocking its action. So this is not the answer. The third answer is damage to voltage gated calcium channels in the axonal terminal. This is the correct answer. So what the immune system does is it wrongly perceives the voltage gated calcium channel as a threat or an external agent, and it basically blocks this voltage gated calcium channel. Uh, and hence what happens is there is no influx of calcium into the axonal terminal, and since there's no influx of calcium into the axonal terminal, uh, the the calcium receptor on the vesicle on the vesicle does not detect this increase in calcium, and hence there is no movement of the vesicle to the presynaptic membrane, and there's no release of acetylcholine into the synapse itself. So this is the correct answer. And then the absence of inhibitory neurotransmitters like GABA in the synaptic cleft. Again, this is not the correct answer. If you recall, there's a toxin called tetanus that is responsible for uh, absence of inhibitory neurotransmitters like GABA in the synaptic cleft. So yeah, this is not the correct answer. So the answer is C. So we'll go on to the next question. Spastic paralysis is caused by botulinum, vesamicol, myasthenia gravis, tetanus. So again, I'll give you 30 seconds to answer this question, and then I'll explain this in detail. Okay, let us see what the answers are. E, okay, A and B. Okay, what about the others? Okay, I'll write down these options here. So this is an important topic. If you know what the neurotoxins are and the two autoimmune disorders, one is myasthenia gravis and the other is Lambert-Eaton syndrome. So if you know this, you can expect questions from a few questions from this in your final exam. So this is an important topic. A and B were the two options. Spastic paralysis is caused by botulinum, besamicol, myasthenia gravis, tetanus. What botulinum does is it attacks the snare proteins, uh, which is so this is the axonal terminal. We have vesicles that once the calcium there's an influx of calcium, the synaptotagmin detects this increase in calcium, and then it starts to move towards this axonal terminal, this the membrane, presynaptic membrane, and it fuses with the membrane, and it releases the the vesicle releases the acetylcholine outside after fusing by a process called exocytosis. So the process of fusing of the vesicle to the membrane, to this membrane, is mediated by these protein called snare proteins. And so there are two snare proteins. One is syntaxin, and the other is synaptobrevin. Okay. So what botulinum does is it cleaves, or it makes the it blocks the functioning of these snare proteins, and hence this vesicle cannot dock or cannot release the acetylcholine outside into the synapse, even though there is acetylcholine here. So what this causes is drooping of the uh, in babies, it causes drooping of the eyelids and other such symptoms. So it causes a weakness. It does not cause spastic paralysis, or there is no rigidity in the muscle. So botulinum is not the answer. Besamicol, we already discussed what besamicol does. Uh, So we saw that inability to pack acetylcholine into vesicles is what besamicol does, and hence there is no release of acetylcholine since it is not packed into vesicles. It cannot be released into the synapse or the neuromuscular junction, and hence there is no action potential generated in the post. There is no end plate potential that is generated in the postsynaptic membrane, and hence there is no action potential and in the muscle fiber. This leads to again I mean weakness, because there is no contraction of the muscles. So again, this is not the option. This is not the correct answer. And what myasthenia gravis does, like I discussed in the previous slide, uh, I don't know where that option is. Yeah, so here it basically it is an autoimmune disorder which attacks the nicotinic cholinergic receptors, and hence the acetylcholine which is released into the receptor into the synapse cannot bind with the nicotinic cholinergic receptors, and hence again there in the situation is the same. There is no end plate potential that is generated in the postsynaptic neuron. So again, that is not the answer. This causes weakness and flaccid paralysis. So what tetanus does? I explained. This is the correct answer. Tetanus. What tetanus does is, like I mentioned before, we have this. This is the synapse. ACH is released, and acetylcholine esterase breaks down some of the ACH into choline and acetate to control the action. If we don't want too much action of ACH in this postsynaptic membrane. If there is too much of ACH, what will happen is there will be a large influx of the action potential, the frequency of the action potentials will be more, and the muscle will always be in a contracted state. We don't want that. So we have this control system kind of mechanism where acetylcholine esterase breaks down ACH. Similarly, there's another neurotransmitter called GABA, GABA, which causes a hyperpolarization in this postsynaptic membrane. So this is another mechanism or another control system to control the effect of ACH. So this keeps the effect, the act, the functioning of ACH in check. Now, if this is not there, what will happen is there will be a lot of the muscle because there'll always be an action potential that is generated. The muscle will always be in a contracted state, so that leads to something called as spastic paralysis, which is caused due to tetanus, because tetanus destroys or makes basically affects GABA, and GABA is not able to do its functioning, that is to hyperpolarize the postsynaptic membrane. So this is the correct answer, tetanus. Okay, moving on to the next question. Which of the following is associated with damage to nicotinic cholinergic receptors? So we just discussed this now. Uh, Again, I'll give you 30 seconds to answer this question. Okay, let's see what the answers are. D. Okay. What about the others? Okay, let's discuss this now. So there's one option D. Which of the following is associated with damage to nicotinic cholinergic receptors? So we saw that tetanus is actually it destroys GABA. So this is not the correct answer. Botulinum, what it does is it affects the snare proteins, which prevents docking of the vesicles. So this is also not the correct answer. Then we have besamicol, which prevents uh, the action of CHAT, choline acetyl transferase. From it prevents chat from functioning and basically packing ACH into vesicles. So this is also not the correct answer. Myasthenia gravis is the correct answer because it is an autoimmune disorder which attacks the nicotinic cholinergic receptors, and hence the ACH, the acetylcholine, which is released into the synapse, cannot bind with the nicotinic cholinergic receptors, and hence there cannot be a, let us recall, the nicotinic cholinergic receptors are ligand gated sodium channels. So whenever acetylcholine is like a key and nicotinic cholinergic receptor is the lock, so whenever ACH attaches to the nicotinic cholinergic receptors, it opens up and there's an influx of sodium, which causes which causes a depolarization in the postsynaptic neuron. So if this nicotinic cholinergic receptor is basically affected in this condition, in the myasthenia gravis condition, so this is the correct answer. C is the correct answer. Which of the following Ca2 plus in order to uncover actin's active sites? So you can just answer this. I'll give you guys 30 seconds. Okay, let's see what the answers are. A, okay. A, C, A and C. These are the two responses. A and C. Okay, so basically, uh, there will be a confusion between this and this because the name is similar. But let us recall what happens. So we have actin. We have the actin, which is a thin filament, and we have myosin, which is a thick filament. So these two are removed from the option, actin and myosin. What we want to see is what uncovers, which binds with Ca2 plus. So tropomyosin is basically what covers the active binding sites on actin. So actin has myosin binding sites, and that is covered by this myosin. So this is not the correct answer. And troponin is the correct answer because when Ca2 plus, when there is increase in Ca2 plus concentration within the muscle fiber, uh, Ca2 plus then reacts with troponin and undergoes a conformational change. And since troponin is attached to tropomyosin, when this undergoes a change, conformational change, it moves tropomyosin, and hence the myosin binding sites on actin are exposed. Now myosin can bind to actin. So the correct answer is C, troponin. Which of the following is most likely to extend along the entire length of the muscle fiber? So this is a straightforward question. I'll give you guys 30 seconds and then we'll discuss this. Okay, let's see what are the answers. B. Okay, two people have responded B. I'm glad you guys are participating actively. Okay, let's see. Yes, the answer is correct. Myofibril extends along the entire length of the muscle fiber. So let us recall that within the muscle fiber, so this is a muscle fiber, we have myofibrils, many myofibrils that are in parallel. So and it extends the entire length of the muscle fiber. So myofibril is correct. Sarcomere is basically the smallest functional unit of a muscle. So this is not correct. And myosin filament is also not the correct answer. M-line and myosin filament because they don't extend. They are just part of the myofibril, but they don't extend the entire length of the muscle fiber. So B is the correct answer. Uh, Question 12. The end of the actin filaments are anchored to the M line, Z line, perimysium, sarcoplasmic reticulum. Again, this is I'll give you 30 seconds and then we'll discuss. Okay, we are done. Jyoti is saying B. Okay. Yeah, that's correct. The answer is Z line. Actin filament, which is a thin filament, is anchored to the Z line. Uh, and of course, these are not the correct answers. You can just directly eliminate them. Let's go on to the next question. When the muscle fiber shortens, the following also shortens: actin filament, myosin filament, sarcomere, or troponin. So you guys can take some time and answer this. Okay, let's see what the answers are. C. Okay, two people have responded as C. Let's go and check what the answer. Yeah, that's correct. Again, this is a straightforward question. C is the correct answer. So we know that the myosin head during excitation contraction coupling, the myosin head, the myosin pulls the thin filament actin from both the sides, and hence the Z lines, the distance between both the Z lines shorten. And we know that the content between two Z lines is actually a sarcomere. Since both the Z lines shorten, it is a sarcomere which is shortening. So this is the correct answer. Yes, you are right. That's great. You guys are responding and also getting the answers correct. So I understand that the content is there's a lot of content and it's not easy. So I would recommend that you guys don't fall behind uh, in watching the lectures, because if you fall behind, it will be very hard to catch up because it's a very fast-paced course. Uh, so and there's a lot of content packed into 1 week. Uh, so I would recommend that every week you stay up to date with this course. So the 14th question is: calcium is stored inside the sarcoplasmic reticulum with the help of a protein called as snare protein, synaptotagmin, calcipoestrin, synaptobrevin. Again, this is a straightforward question. I'll give you guys 30 seconds and we can then discuss this. Okay, let's see what the responses are. B. Okay. B, C, C. Okay. C. Okay. B and C. Okay, let's see whether this is correct. So we have to B or C. So let us recall what happens. Calcium is stored inside the sarcoplasmic reticulum with the help of a protein called as snare protein, synaptotagmin, synaptobrevin. So synaptobrevin is actually a snare protein. We know that there are two snare proteins. One is syntaxin and the other is synaptobrevin. So these two options are eliminated because snare proteins are involved in docking of the vesicle onto the presynaptic cell membrane and then releasing the acetylcholine by a process called exocytosis. So these two are eliminated. So they don't have, these are involved in the presynaptic uh, membrane. Calciquestrin is involved in the postsynaptic membrane within the muscle fiber. So B is synaptotagmin. Again, this is related to this is the sensor that is on the vesicle in the presynaptic membrane. But this question is related to the postsynaptic membrane. So you can see that the answer is calciquestrin. So this is basically a protein which binds, which is within the ICF of the muscle fiber. We have sarcoplasmic reticulum, and within the sarcoplasmic reticulum we have this calciquestrin, which binds up to 50 calcium ions. Okay, so this basically packs a lot of calcium ions into the sarcoplasmic reticulum. So the answer is C. This is correct. Moving on to the next question. Head of myosin attaches to the binding site in actin and undergoes a power stroke when A. When ADP is hydrolyzed to ATP plus PI, PI is released. ADP is released from myosin when calcium is released. So again, I'll give you guys 30 seconds and let's see what the answers are. Okay, let's see what the answers are. A. Okay. Aishwarya is saying A. So let us recall what this question is related to, which concept this question is related to. So there are a few important concepts. One is the neuromuscular junction, right? How information is transmitted via the via chemicals across the neuromuscular junction. So NMJ is an important concept. The second important concept is excitation, contraction, coupling. So how does excitation in the postsynaptic membrane causes contraction in the muscle? This is the second important concept. And the third important concept is sliding filament theory. So this question is related to sliding filament theory. So let us recall what happens. So the correct answer is actually B. When PI is released, there is an release of energy which causes the power stroke. So what happens is initially we can start the explanation of the sliding filament theory from any place. So initially what happens is, let us say that the muscle is in a rigor state, that is the myosin head is strongly attached to actin. So this is called the rigor state, and there's no ATP attached to the myosin head. So we know that the myosin head has actin binding sites as well as binding site for ATP. Uh, so what happens is when there is no ATP, the actin is it is called a rigor state, and in death when there is no ATP, what happens is the myosin head is strongly attached to the actin, and it's in a rigid state. So that is called rigor mortis. So initially, let us say that in this cycle of sliding filament theory, uh, the myosin head is strongly attached to actin without, and ATP is not attached to it. So it is currently in a rigor state. Then what happens is ATP attaches to the myosin head, and uh, then myosin loses its affinity to the actin binding sites, and it is released. So there is no attachment anymore. So now what happens is after this ATP hydrolyzes to uh, ADP plus PI, okay, and now the myosin head is in a high energy state, and it is loosely attached to actin. Then what happens is when there is a calcium spark or a calcium influx, the actin binding sites are exposed, and now the myosin head strongly attaches to the actin, causing strong cross bridges. Then what happens is the potassium is released, and then there is an expenditure of energy due to which the power stroke happens and there's contraction. So the correct answer is B. PI is released. Okay, so the rest are not correct. So if you know the sliding filament theory, entire process of sliding filament theory, then you can answer any question related to. The next question is, okay. So this particular question we'll discuss in the next class. There are two questions that we'll discuss in the next class. We'll go on to this. Following is the correct sequence in excitation contraction coupling. So I'll give you guys a minute. This is slightly more advanced, one and a half minutes, and then I'll discuss this particular question. Okay, let's see what the answers are. B. Okay, two people have responded B. Okay, let's discuss this. This is the answer that is given. Huge outflux of calcium from sarcoplasmic reticulum, activation of ryanodine and dihydropyridine receptors, calcium restored in sarcoplasmic reticulum through the calcium pump, arrival of action potential towards the T tubule. So this is the first step that happens. First, there is an action potential that is generated in the postsynaptic membrane. in the neuromuscular junction, that is in the muscle fiber, and that action potential travels along the muscle fiber towards the T tubule. And then what happens is it activates the dihydropyridine receptors, which in turn activates the ryanodine receptor through something called as foot processes. So this is the second part. And then ryanodine receptors are basically, they open up like I told in this step, causing it. These are calcium gated. These are calcium channels. So what this does is, once they open up, there's a huge outflux of calcium from the sarcoplasmic reticulum into the ICF of the muscle fiber. So this is the third step. And then finally, calcium is restored into the calcium sarcoplasmic reticulum through the calcium. So the answer should be 4, 2, 1, and 3. 4, 2, 3, and 1. 4, 2, 1, and 3. C is the correct answer. I think these two steps got interchanged for those who answered B. So the answer should be C. Moving on to the next question. So I told you there are two questions, 16 and 18, that we'll discuss next week. We'll go to the 19th question. A trigger to initiate the contractile process in the skeletal muscle is A. Potassium binding to myosin, calcium binding to tropomyosin, calcium binding to troponin, ATP binding to myosin cross bridge. So again, 30 seconds for this. Okay, let's see what the answers are. C. Okay, Aishwarya has responded C. Yeah, I think you're right. So potassium binding to myosin. This is the wrong answer. Potassium does not bind to myosin. This is not what triggers the contractile process. Calcium binding to tropomyosin. Calcium does not bind to tropomyosin in the first place. That's wrong. ATP binding to myosin cross bridge. This is also wrong. This is what releases the. This is what decreases the affinity of the myosin to the actin. So the correct answer is calcium binding to troponin. So when calcium binds to troponin, troponin undergoes a conformational change, releasing the active binding sites on the actin, and then there's a formation of cross bridge between the myosin and the actin. So this is what triggers the uh, contractile process. So the answer is C. Moving on to the next question. Which of the following is not associated with botulinum neurotoxin? So recall the question is not associated. I'll give you 30 seconds to respond to this. Okay, let's see what the answers are. B. Okay, Aishwarya has responded B. Okay, let's discuss this. B is one of the responses. Okay, which is not associated. So, if you recall, botulism causes flaccid paralysis, right? Not spastic paralysis. So, this is not associated with botulinum. Rigidity and spasm is not again not associated with botulinum. Weakness and flaccid paralysis is associated with botulinum. Death, sometimes the botulinum toxin reaches its effect reaches up to the lungs and it can lead to death. So these two are associated, and rigidity and spasm is not associated with botulinum toxin. It's associated with another toxin, right? That is tetanus. Uh, Similarly, spasticity is associated with tetanus. So these two are the correct answers. These two are not associated with botulinum. So the answer should be A and B. So you are partially correct, Ashwarya. Also, this is you can have multiple correct answers. So A is also the correct answer. A and B. Uh, Now moving on to the next question. Which of the following statements are correct? So again, there can be multiple correct answers here. So I'll give you guys 30 seconds. Okay, let's see what the answers are. C and D. Okay, Ashwarya has responded. Okay, let's go and discuss this. C, D are correct. So, besamicol blocks acetylcholine receptors in postsynaptic terminal. No, this is wrong. We have already discussed that besamicol prevents the packing of acetylcholine into vesicles. Botulinum reduces the ability of vesicles to interact with snare proteins. This is correct. Let us recall that botulinum attacks or cleaves the snare proteins, and hence the vesicles cannot interact with them, and due to this, ACH cannot be released into the postsynaptic into the synapse. Then Lambert-Eaton syndrome is associated with blockage of calcium channels in the presynaptic terminal. This is also correct. And tetanus competes with acetylcholine to bind two nicotinic cholinergic receptors. So tetanus is basically it attacks GABA, the neurotransmitter GABA, and hence, like we discussed in one of the previous slides, this causes excess action of acetylcholine. And since acetylcholine is unchecked, this can lead to the muscle being in a contracted state. So D is wrong, not the correct answer. Tetanus is not involved does not compete with acetylcholine. It's tuberculorin. Let us recall. There's there is another a neurotoxin called tuberculorin, which competes with acetylcholine to bind with nicotinicholinergic receptors. So the answer is B and C. So I think you got Aishwarya got this part correct. That's great. We have a few more questions to discuss, around 1, 2, 3, 4. We'll continue that next week. It's already time. It's 6:05. If you guys have any further questions, you can let me know, or we can wind up the session and we can meet next week. I hope this session was useful to you. Uh, so, unless there are any questions, I'll wait for a minute. Unless there are any questions, I'll end the session. Okay, Bosu Babu, I will forward your uh, request to sir. I'll inform him that about your request. Okay. Okay, everybody. I don't think there are any further questions. So I'll wind up the session now. Thank you for joining in. Purely engineering background, so kindly accept my request. Thank you. Okay, Bosu Babu. I'll convey this to sir.
Thank you, sir. Thank you very much.
Okay. 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 I'm closing the session now. See you guys next week. Bye. Thank you, Jyoti.
Bye,
Thank
sir.
you, Ashwarya. Bye.
Thank you very
Bye,
much.
Bosu Babu. Bye. Thank you, Ashwarya. Bye.